My friends, welcome back to my 200 3D CAD problems in FreeCAD series. Today I want to work on exercise 12. Exercise 12 is a little bit similar to what we did in exercise 11, but not that much similar. So it's a little different, and I decided I will be doing this exercise in part workbench. As you can see, I have already loaded the image on FreeCAD and I already processed that too. The axis cross is set at the center of this big circular hole, and this model has practically two cylinders connected with an arm, flat arm, but this larger cylinder has an indentation between two outer walls. So what I'm thinking is I will build this model as a revolution, and I will build this as a primitive and then make a connection in between. So let's jump into it. As I said, I want to build this one as a primitive. So we have tube in there. It would be easier. So outer diameter is 38. So outer radius would be 38 over 2. Inner radius is 20. Diameter, so 10 radius, and height is given as 30. Now 30. Okay. So as you can see, the tube is placed at the center of our sketch of our workplace, and we don't want to do that. We want to move this object to its place, which is 75 millimeter away towards y direction. So we can do that in the placement tab. On position, as I said, it is on the y direction, upper side, so 75, that takes to its place. I also want to make that symmetric by the plane, so symmetric against xy plane. So xy plane, if we have to change anything on xy plane, the axis would be z. So if we increase that, it goes away. We want to take it the other way, and because the height is 30, I think we'll have to go to minus 15. So that was easy. That primitive was easy. Now I want to work on this part. So that part, I think I can connect this middle part while I'm on the xy plane. So let's go ahead and then work on the connector plate. So xy plane, I want to create a sketch, and I want to pull in this geometry, or I can make that independent. So on this sketch, I can draw, maybe I want to do that, maybe I want to pull in that geometry here. So that way we will get this center reference. All right. Now I can draw an arc from there. All right. I want to make this on the axis cross, and I want to make another arc here. All right. And this radius is 64, so let's go ahead and then build an endpoint and rim points arc in between these two. I want to make the tangential here. I also want to make the tangential with this one too, and make this the radius 64. So what else we're missing? 1 degrees of freedom, and that is the height between these two. The height would be easy. All right. So this radius we can find out from the sketch. It is 64 diameter, so 64 over 2, that's the radius. Okay, that constrains everything. So we got that connector part, half of it. So let's go ahead and then rename that as sketch half connector. I want to extrude that by 10. I want to make that symmetric. So there is that. Now I can mirror that against this line, which happens to be YZ plane, which happens to be YZ. So YZ plane. All right, that gives us the full connector. I want to make that a fusion and write that as connector. Okay, so this is the tube, this is the connector, and now we'll have to work on the cylinder, the big cylinder. The big cylinder, what I plan is I want to draw this bare bone, this sketch, and then want to revolve it against this axis, which is x axis. So if we want to revolve something on x axis, we'll have to create that sketch on YZ axis. So if I want to create that sketch on YZ axis, let me go ahead and then place this image on YZ, so that way we can use that on our advantage. Let's actually, so this part is this part, so let's do some orientation. Okay, so here what I want to do is I want to transform this image to match with what we got so far. It doesn't have to be exact. In the close proximity will work. Now, to someone, the close proximity could mean 2 millimeters. Someone say no, 0.2 millimeter is close proximity. Both of them are fine. As long as you feel you are in the close proximity, you're all right. All right, so we got the sketch lined up with our object. Now what I want to do is I want to pick this part or maybe this part, either way. So this is the right, and I want to do on this part, so that way all my dimensions will be positive. I want to draw and sketch on YZ plane, right? And because it will be a revolution, I want to do only one wall. So this wall is what I'm planning to draw. So the drawing part is done. Now constraints, we can find out this length. This length is 64 minus 34 divided by 2. Right? Yes. So this length is, we are trying to put in a formula, 64 minus 34 divided by 2. So that's 15 millimeter. And the distance between these two is 34 divided by 2. So the distance between them is 17. Okay. We can find out this length as well, but I can just say the distance between these two is 43 over 2. 43 over 2. Okay. In the same fashion, we can say the distance between these two is 55 over 2. 55 over 2. That does the trick. The last one is this. The distance between these two is 64 over 2. 64 divided by 2. Oh, that's already given. Okay, so we don't have to do that. Now what else? So we are missing this length. I can say the distance between this point and this axis is half the 30. So 15. That binds something. We can say the length of this total line is 30 plus 15. So that is 30 plus 15. The distance of this line, this distance of this vertical line is 30. It is given here. Okay. And now we have one more, that is this. So the distance, they say is the gap is 5, so that's this line, the distance is 5, so that constrains everything. So that's our sketch, we got that sketch. Now what I want to do is I want to revolve that sketch against this axis, this line. So we got this sketch, I want to revolve that against this line, which is z axis. So z axis is there with 360 degree. Let's see. Yep. Okay. Something wrong. What? Something's wrong here. Nope, there it is. It was a fluke. All right. So we got our 3 parts separately constructed, and now I want to make all of them a fusion. So now I can say this is our final object. Let me see if that matches with our image. Oh, what I can do is I can do a refine, so that way everything looks great. That's actually our object. That is our object. Tell you what, I will do some more transformations, see actually if that makes sense. Okay, yeah, that's our object. That was fairly easy, and I hope you liked this process. Thank you for watching the video. I'll see you in the next one. Bye.